Hello everyone. Yesterday we did for the first time ever we had a meetup and we did a testnet preview. Some of you guys had trouble looking at the screen, so I thought I'll do another video which is with just the screen, so you can see the testnet demo again. I'll not go through the entire presentation because I will link the YouTube video with the entire meetup presentation I did yesterday below. But in this one, I'm just going to focus on the testnet architecture and just jump right into the testnet itself. So like I covered a lot of material yesterday, which you can see in these slides. Just go back to the link that is below, and then you can see the entire presentation. And the cool thing about that presentation is it's straight out of our camera, Live Planet camera, which we streamed live from our San Jose office here. So it's pretty exciting. So please do take a look at that. And this one, we will just mainly focus on VideoCoin architecture um, and the testnet itself. So like these parts explain how we have implemented proof of transcoding using a perceptual hash function, which I've covered in depth in our blog, and you can take a look at it. We've done a lot of performance measurements that you can see in these graphs, and also our philosophy behind verified nodes, and then the consensus mechanisms we use. So do take a look at these things, and we hope you find that informative. So jumping right into the VideoCoin testnet, right? So like the overview of what we've done with the testnet is we've built it on top of the Ethereum network. And then when we say it on top of Ethereum network, we want to be clear that it's not an ERC20 token. It is a native protocol built on top of the Ethereum blockchain source code. So we really like the Ethereum project. And I've said this multiple times before as well, because it is because of its maturity, because of the community support, because how well the network is tested. It's one of the best projects out there, and then it makes a lot of sense for us to use a lot of the battle tested technology that Ethereum provides. So like it's built on top of GETH. So we've taken that, we've removed the proof of work part of Ethereum because that's not relevant for us. We replaced that with our proof of transcoding. Again, there's like a long explanation of why we've done what we've done in the other video, but you can take a look at this. Our encoders are based on FFmpeg, the most widely used open source encoders out there. And our ingest pipelines are all based on RTMP, Nginx RTMP, and Handlebar Nginx. Our networking and the gossip layers is built on top of libp2p, and our API layer, we're building an API layer on top of Web3, which is basically a RESTful API on top of Web3. It's as of now, it's hard for me to show what it actually means. You'll see in future blog posts on what it, on more examples of how we have extended the Web3 API to actually power video encoding specific operations. And the network itself is based on top of proof of authority. So like we have issued certificates for the nodes that are performing the mining in this, and then as in a part of our roadmap, we'll be starting off with proof of authority and then gradually building out to a place where we have proof of stake based consensus mechanisms in place. That brings us to the demo. So what I'm going to do is I'm SSH'd into our Google Cloud here. So what I'm going to do first is so the first thing we're going to do is bring up the Ethereum network that we're using. So like the Ethereum network is pretty much, like I said, we've removed a lot of the stuff that we do not need there, and then built on top of that to use a proof of work that's actually useful for us. So like, let me bring that up first. So this step brings up our private proof of authority based VideoCoin blockchain network. So like this is right now mining video coins right now, and For more detailed explanations on the architecture, there's another video that, like I said, we can check out. But what this does is I can now go and bring up a block explorer for this developer network. You see this, right? So like we just now launched the network, so there's just like 8 blocks written out there. It's just 8 blocks, and you can see the wattage limit here. The wattage is described in depth in our white paper. You can take a look at it. We're also working on additional blog posts and explains what wattage is. But you can see the watt limit, and with 5 nodes up and running in this VideoCoin mining network. So in this case, node 0 and node 1 are what we call a sealer nodes. So these are the 2 nodes that are actually writing the blocks, and node 2, 3, and 4 are the mining nodes. So in this particular setup, node 3 and 4 are compute miners. So you can see this. Oops. All right. So you can see this better. You can see that node 0, node 1, and node 3 and 4 have 0 video coins in their wallets because they've not done any mining work. So that is where things are starting off. So you can see that there's a block explorer with node visualizations, and you can see new blocks getting written every 5 seconds. So like we've also done a lot of throughput analysis and transaction analysis, which I've covered in one of my previous blog posts as well as in future blog posts, where you'll see what kind of TPS that we can hit for these transactions. But this is the overall block explorer, right? And now that we have the block explorer, now that we have the basic Ethereum powered VideoCoin network up and running, what we'll do is like we'll go and we'll bring up the miners. So in this case, I'm bringing up the mining nodes we have, the transcode miners, which are basically compute miners, storage miners, and then the distribution miners. So like all of these are running as a part of the light nodes that we configured here in the network, and then they begin mining right now. So they're now available to take jobs and start mining. So what we'll do next is we'll go and start up our verifier node. So again, verifier node is something discussed in depth in our white paper. You can take a look at it, but I'm going to start the verifier node here. And what this does is it brings up the verifier node, which does the perceptual hash compute, and then waits for a stream to come in. So in this case, like it's saying playlist not available, try again, waiting. What that means is there's basically no video stream coming into the VideoCoin network. So this is a perfect spot for us to feed an actual live stream into the network. So what we'll do is, like, instead of using any network, we will use a real stream from one of our cameras, from one of our Live Planet cameras. So you'll see this network this camera interface. Right now, this is from our camera. It is basically stitching a 360 video in real time. It's actually stereoscopic 3D. The top image you see is the left eye, and the bottom image you see is the right eye. So it is stitching 16 cameras worth of images in real time, encoding it and streaming it on the internet. So like what we will do is we'll take this we'll take this stream that's coming right out of our camera and send it into our VideoCoin testnet. So in this case, what you're seeing right now is an option that you can stream directly to Live Planet Cloud, which is our cloud, which is the basis of all the video encoder work that we're doing. So like all of the we've built a massively parallel distributed transcoding engine for Live Planet. So it'll go to that platform. We don't want to do that. We want to send it to a custom platform, which is basically VideoCoin. So what we will do is, like, we've gotten this thing to up and running here in this IP address. So I'm going to bring it back here, type the address, specify the port, and give it a stream name. So what this does, STREAM, or stream, and give it a stream name and start streaming. So this basically started the live stream into the VideoCoin test network that we've just now built in the terminal. So now what we'll do is we'll start watching the verifier node to see if it starts picking up the stream. And there you go. So this right here, I'm going to stop this terminal from scrolling. So you see this, right? Like this is the verifier node picked up the source RTMP stream, picked up the destination player list, and it started verifying it. So in this case, it's calculating the hash distances here. This is the hash distance. It's saying that the p hash distance check was a success, and it's going on doing that for every single chunk that is coming into the verifier node. So this means basically that the verifier node is acting as a verifier between the client and the miner node, and then checking transactions. To finish up the demo, let us now go and see if this video stream is actually playing, and we do that by going back into the Google Cloud instance where we had the stream running. HLS, let me get that stream. And let me get, so here in this case, the miner is actually mining 3 different bit rates. One is the original bit rate, just the forward, and then one is another one with the medium quality, and then one with a high quality. So what we will do is we'll just take the medium quality, M3U8, and see if it plays. And there you go. So this is exactly the same live stream that you're seeing in our camera control page here. That is streaming directly from the VideoCoin testnet in 4K. So like the reason why this is very impressive and a very difficult problem for us to have solved is our camera is outputting 4K at 50 megabits per second. Right? This is hitting our the VideoCoin testnet setup in Google Cloud, and the miners are actually taking the entire 4K stream and transcoding it in real time into 3 different bit rates and sending it through the internet, so that it comes and plays in M3U8. And one of the most important things that we need to see here is like all the transactions that are flowing in through the block explorer. So these every time there is a confirmation that happens by the verifier node here. So each time a verifier node confirms a transaction, it is reflected here in the block explorer, and you can see here these transactions reflect to a direct VideoCoin deposit into the miner nodes, because the miners earn mining fees in VideoCoin network, and then the verifier nodes write the blocks. So you see this, right? Like VideoCoin node 3 and 4 are the 2 miners here, and they're earning VideoCoins as they're making more and more transactions. So this basically completes the entire loop of an RTMP stream going straight from our camera into our testnet and streaming back out of the testnet. You can see Jason here, you can say hi to him, and coming all the way back and sealed into a transaction here in VideoCoins. So that is our demo, folks. So like this is work in progress, but as you can see, we made a lot of progress over the past few months. We've built a lot of technology. We've leveraged a lot of things that we've built for Live Planet, and especially the distributed encoder, and we've finished an end-to-end loop of having an actual RTMP stream coming into testnet, getting transcoded and converted to HLS and sent back into the into the network. Sent back into the player. So this is very exciting for us. Do check out the other full VR stream that was again streamed from our camera. So it's very exciting for us to have shared this demo with you guys. So please stay tuned, follow us on our Telegram, check out our Medium blog post, and just stay in touch with us to know what's the latest in VideoCoin. So thank you.